Alright, our video that we're going to look at today is our video on what we call direct and inverse variation functions. And so your essential question or your objective will be, how do I solve and graph direct and inverse variation functions? So let's take a look. So here's our two functions, or our variation functions. This is our direct variation function here. We say that y varies directly as x. And over here we have our inverse variation, and we say in inverse variation, y varies inversely as x. And go ahead and take a look, kind of compare and contrast what the two formulas look like. Over here we have y equal to k times x, and over here we have y equal to k divided by x. So quite a bit of difference in here. And if you come down and compare and contrast your graphs, you see that in fact your direct variation graph is a line, and in fact it is a line that goes through the origin. Over here we have two curves. We have a curve occurring down here, and we have a curve occurring up here. You notice that they're getting really close to that y-axis where x equals 0, but it's not going to get there. And that reason is, can we have x equal to 0 in our denominator? No, we can't, right? We don't know how many times 0 divides into a number. So your inverse variation will give you a graph that looks like this. Okay, and let's go back to our direct variation, and we're going to look at that one first. A direct variation equation is a linear equation. Of course, we get our line. And if we keep it in the form of y mx plus b, we see that b is equal to 0. Therefore, our y-intercept of 0, that's why it's going through the origin. And the constant of variation, our k in this case, is actually the slope of the line. And again, because b equals 0, here's a pattern. Your direct variation will always pass through the origin. So let's write a direct variation function here. Okay, let's say we have y varies directly as x, and y equals 27 when x equals 6. So we're going to write this particular function, and then we're going to graph it. So to write the function, we're going to start off with our standard form of y equals k times x. We're going to put in the values they told us, our 27 and 6. And then at this point, we're going to solve for k. So that means we'll divide by 6 on both sides, giving us a constant of variation of 4.5. So we will rewrite our function, and we will replace our k. So there is your function. Now let's graph it. So we know if we look at y equals mx plus b, we know that 4.5 is our slope, and our y-intercept, of course, is 0. So we can put this into our calculator and graph that, and we end up again with a line going through the origin. You can check to make sure that you have solved this correctly by putting back in your two original values, 27 and 6, and make sure that your left side equals right side, and it does. Alright, let's look at our second type of variation. Now what's going to happen with our inverse variation is a situation where one of our quantities is going to increase and the other decrease. Now it could be x increasing and y decreasing, or it could be vice versa. So if we come over here and look at our table, this table shows the time needed to drive 600 miles will decrease as our speed increases. So let's look. So if these are our x values over here, we start off with 30 miles per hour. It would take us 20 hours to go 600 miles. If we increase our speed to 40, it's only going to take us 15 hours to go the 600 miles. So as you can see here, our x values are increasing as our y values are decreasing. So this is what we call our inverse variation. So it is a relationship between our two variables of x and y, and in the form of y equal to k divided by x. This will occur when k is not equal to 0. So for this equation, we say y varies inversely as x. So let's try one of these. Given y varies inversely as x, and y equals 4 when x equals 5. So let's do the same thing. We're going to write the function, and then we're going to graph it. So we're going to replace, or we're going to start off with the equation. Now we're going to replace or sub in our y and x. We're going to solve for k, so we're going to get rid of that 5 by multiplying both sides by 5. And so we would get that k equals 20. We're going to rewrite and replace our k. Now we're going to take this and we're going to graph it. We can put this in our calculator. Now what we're going to do a little bit differently here is to graph it. We're really going to make two tables of values. We're going to make a table of values for the positive and then for the negative values of x. And then we're going to plot them. So if we take the negative values of 2, 4, 6, 8, we get our y values here. And if we take the positive values of 2, 4, 6, and 8, we get our y values here. So we come over here, we plot the negative 2, negative 10, negative 4, negative 5, right there, our negative 6, negative 10 thirds, and our negative 8. And we connect them with this curve. Remember, we're not going to reach this because we know x cannot be equal to 0. So we get our curve down here. And then with our positive values, we're going to get our curve right here. And there's your graph. Okay. I want you to stop or pause the video, take a few minutes, and I want you to do the same thing we just finished doing. You have a varies directly and a varies inversely problem, and I want you to work those out. When you're done, restart the video to see if you got your answers correct. Alright, let's check. For your first one, your formula was y equal to 0.5x, and your graph, so that you had a slope of a half, so here's your graph. Again, it's going through the origin. Down here, your y varies inversely as x. Our formula is y equals 40 divided by x, and your graph is going to look like this. So you had your negative values of x and your positive values of x. Again, our two curves never reaching the y-axis. Alright, so in summary, what we learn? Direct variation occurs when both x and y are increasing, or they are both decreasing. If they're decreasing, that's going to be a negative slope. And look down here at your graph. This would be where they are both decreasing, your negative slope. Your inverse variation, where x is increasing and the y is decreasing, or if x is decreasing, your y will be increasing. Think back to our example about the if you increase your speed, then your time is going to lessen to get where you're going. Alright, so I want you to use your definitions and think about your graphs. You have your graphs in front of you. And I want you to answer these 5 questions on your worksheet and bring that back to class, and we'll see how you did, and we will finish up the worksheet in class.